Okay, so here is an exponential problem with several parts. I will cover part A in this video, and then the parts B, C, D, and E in the following video. We know that 24 customers arrive in 1 hour. So essentially that means 60 minutes. 24 customers arrive in 60 minutes. Now looking at the questions that we have to answer, it's a probability that the next customer arrives in 1 minute. What is that? We want to compute that. Probability that customer arrives in 30 seconds, so that's half of 1 minute. In 15 minutes, after 10 minutes, 12 to 15 minutes. So everything that we're doing is in terms of minutes. So our lambda, or our arrival rate, must also be expressed in minutes instead of hours. So 24 in 60 minutes is equal to 0.4 in 1 minute. So our lambda, we have decided, is 0.4 per minute. And that is what we're going to be using for the remainder of this problem in terms of the lambda. Now we also know that your book says that the probability of x being less than or equal to a is equal to 1 minus e to the power of negative a times lambda. So a will vary from problem to problem. For example, in part A, we're going to put 1 for it. In part B, we will use 0.5 for A because it's half of a minute. Then 15, etc., etc. So let's get started with part A, which says, what is the probability that x will be less than or equal to 1 minute. So probability that the next customer arrives in 1 minute. Now from a graphical perspective, here's my very poor attempt at graphing this. I'm going to mark it at 1 minute. This is time across this axis right here. This is time. And probability of less than 1 minute will be this area to the left of 1. So probability that the arrival of the customer will be within the first minute. So to compute this, we will apply this equation that your book gives us. And plugging in for A and for lambda, we get 1 minus e to the power of negative 1 times lambda, which we computed to be 0.4. So using our calculator, I'm going to first initially solve for this e part right here, this e term, and then I'm going to subtract it from 1. So here is how we're going to plug these numbers. I will clear out. At the exponent, we have negative 1 times 0.4. So what happened to my calculator? Here it is. Okay, so I'm going to put negative 1, push the plus minus sign to make it negative, times 0.4, and that's negative 0.4. That's what it equals. Then I want to take e and raise it to the power of this number. So I'm going to put second function and push the natural log button, ln. So what you see on the display, 0.6703, is 0.6703 is this e term. Then I need to subtract that from 1. So here is my calculator again. I keep losing my view. Okay, so here's my 0.6703. I want to change that to be a negative number, so I push the plus or minus key. Once it's negative, I'm going to say add 1, plus 1. And the answer, of course, is going to be 0.3297, as you can see on the calculator display. So what we have is this area that I was after. We can see that that is equal to this number right here. So approximately 33% of the customer, there's a 33% chance, or a 0.33 probability, that a customer will arrive within the first minute. The next video will take you through parts B, C, D, and E. But before I go there, let me just tell you that whether I say probability of X of customer arrival being less than or equal to 1 minute, or within the first minute, or probability of the customer arrival will be less than 1 minute. Both of these have the same answer of 0.3297, and that's because the probability of an exact value for a continuous random variable is 0. So whether I say less than or equal to a minute, or equal to or less than a minute, they're both the same probability.